everyone. For today's lesson, make sure you complete the warm-up in AP Classroom. It's Unit 3, Day 1 warm-up. 5 questions. Those go in Power School. And then I did want to make a comment about our Unit 3 packet. So for Unit 3, we have the packet printed for you, and it started with what's wrong with these surveys. Now, you guys did that lesson last class after the Unit 2 quest. And so now we decided to switch things up a little bit. And so it's a lot to do with the content. It makes it a little bit more streamlined. And then the context of the problems is a little bit more relevant to you guys, hopefully. So if you'd like to deconstruct it, what you're going to do is just take the packet, and then you can remove the Justin Timberlake activities and remove the one that says, would you fall for that? What that will do is it will keep all the important ideas boxes and all the check your understandings there. And then you can just put in the new lessons as we do them through Canvas, and you can print them from there and reattach it all together at the end. So today's lesson is in Canvas, and you can get it from there. So there's 2 things that we want you to open and print. One of those things is data, and that is what you're going to use to collect data for today's lesson. So it's just 2 pages, and it's got some information about some neighborhoods. And then notes is the worksheet that we'll be writing on, like we do with our other notes. And so that is data and notes, 2 documents. Hopefully you can print them ahead of time before you start this activity so that you'll be able to write on them and take notes the same way we always do. If you weren't in class today, then what I want you to do is use the join code from Canvas. So we'll put a join code in there. That way you can see everyone's data from Canvas, and then we'll be checking that you joined it with that code to make sure that you recovered all the work that you missed from class today. And then if you weren't in class today, what you can do is go ahead and do the entire Desmos activity, not just slide 1, but the whole thing. So start with slide 1, and then you're going to follow along with the worksheet and the data that you printed out, and you will add your points to the graphs and explore some different sampling methods that way. So if you were in class, then we're going to start here going over it. And if you've just finished the Desmos, if you weren't in class, then pause here so that you can complete the activity and then unpause it to see some of the debrief. Okay, so for the first sample, you were supposed to select 5 homes that you think are representative of the whole population. And so you think that is not random. And so on that one, you just picked 5 homes that you thought looked like a good mix of all the homes, and then you calculated their incomes and found the mean income. And so that's what we're calling here a judgment sample. It's not random. What we can see, this is sample data, not from your class, but just in general. So what we have here is the X represents each student's sample mean. So all of you guys got a mean, and then you put that value on the dot plot, and then it graphed it all for you together. So you should have your own graph drawn here, not necessarily this one. But what most likely happened was that the center of all the means that you guys got, your averages averaged together, is probably not close to the true value. The true value is here, and that's going to be from the population. But your sample value is here, and so I'm going to put here average of sample means. And so what that shows us is that these are not the same. And so we're going to call that a biased estimate. And that is when the population value is not equal to the average from the samples. And so it's biased because it's, in this case, underestimating. We overestimated because R value is higher than the population. So that's biased. And that's because it wasn't random. So non-random samples are often biased. The next thing that you did was you used the random number generator in your Desmos activity to randomly select 5 homes. So that someone had numbered the homes 1 through 100, and then we used a generator that will just get us 3 or 5 numbers between 1 and 100 that we can use to then write down the incomes. So we had labeled them. That was our step 1, label the home numbers, and then we randomly selected them with a random number generator. So sometimes we'll say like random number generator between 1 and 100, and then we selected 5 different homes. We wouldn't select the same home twice. So this one is random. Random is good because what you can see in the graph that we get is that in this random sample, the actual is close to the average from the samples. And we call that unbiased. An unbiased estimate. Typically, random samples are going to be unbiased. So our actual was much closer, especially right now you might be looking that they're not exactly the same, but much closer than this one. And so that was much closer. A simple random sample is going to be the most basic one, where you just take your sample or your population, you label them, and then you select a certain number of each without doing anything special first. The next kind that you guys did was called a cluster random sample. And so this one, it's also random, and what we can see here is that these values are close to the truth. And so that makes it unbiased again. And then what's special about a cluster sample is that it's based on convenience. So we found the home on the map as well as the 4 homes located closest to it. And so it's based on location. And then what that does is it makes it pretty easy because you were just taking all the values close to it. And then what happens though is, notice here, it's close to the truth, so it's unbiased, but in this particular case, it did have a lot more variability. Because the larger variability was due to the fact that we were sticking to specific areas. Okay. So then our next one that we did, and sorry if you're having to go back and forth between the two, but I wanted to make sure that the description had a little bit of notes and the overall graph had a little bit of notes, so you might be flipping back and forth between the pages. Remember, you can pause these videos at any time to catch up or anything like that. So the next one, stratified random sample, is one where we had a separate page that said strata by race ethnicity, in which the homes were divided by their predominant race. And so what I'm going to write here is strata by is another synonym to say like sort by, and then we used a characteristic based on a characteristic. And I'm going to add a little extra that may affect the responses. And so we think that maybe the race, ethnicity might affect the different incomes. And so we use a random number generator to select one home from within each of the 5 strata. And so what that does is it gives us a very representative sample. So within each of the 5 strata makes it guaranteed to include all groups, which is great. And then for this case, we have a little extra notes with the calculator. Just what we could do is if you have them numbered, then you just select one from each separate group. So for example, they discuss here that we use 67 to 71 are the only Native American homes, and we're going to select one of those, and then we'll do it again for each of the other types. And then we can average those. And what I want you to notice here is that a stratified random sample in the graph, so you can flip over to the graph page now. Stratified random sample has close to the actual value, so that means that it's unbiased, which we love. Hopefully you're noticing that all of the random ones are unbiased. And then the other thing is I want you to notice how it has much lower variability, because where it's more precise. And that's because we were able to kind of get one of each type, and that way it always averaged to something close to the true value. So that is some stuff about stratified. We sort the population first, and then we select some from each group. Okay, now the very last type of sample that we did was called a systematic random sample. And so in this case, we selected a number between 1 and 20 for our first home randomly. So we start with the random number generator. Still, it's always random. And then we added 20 to each previous number. And so what we say is then select every nth individual. And so that is systematic. And so in this one, we start random, and then we get systematic after that. And so because of the randomness, when you look at your graph, hopefully you'll see we got close to the actual, which again makes it unbiased. And then it looks pretty much like the simple random sample. So it included a bunch of different types of homes. It was representative of the population, all of that. And so it's close to the actual, it's unbiased, and it's got moderate variability. So if you look back at all these, I'm going to add one more note to each one. Systematic, well, yeah, I'm not going to. We're going to leave it how it is. The main thing about this stratified one is this, oops, I erased it on accident. The main thing about that is the lower variability, so make sure you have that written down. All of the random ones were unbiased, and then the non-random one was biased, and that is a really key thing. That's why it's so important to take random samples, because your non-random samples are not representative of the population, and their values that we use to estimate the population values are wrong. And so that is very important. So in the important ideas box for your notes, like I said, we're still using the important ideas box from this day. So make sure you can find that. At the top, it says, let me make sure I find the right one for you. Topic 3.3, random sampling methods. And so I'm just going to write that down right here. I want you to find topic 3.3, random sampling methods. And then you're going to take your notes from the important ideas box in there. And so it's a lot of the definitions of each type of sample that we did and the benefits of each, and then the process for conducting each. So make sure that you take some time to really pause this next screen and get all of this information down. The first thing, though, I want you to make sure you notice is the population versus sample. The population is the entire group of individuals we want information about, and the sample is the subset of that population. And so the most important thing is a random sample will produce an unbiased estimate, and a non-random sample will be biased. So then I'm going to zoom it out. Whew, there we go. I'm going to zoom out and keep it like this for, hold on, let me see if I can get a good picture for you guys. There. Okay, now what you can do is pause the screen and then you can copy everything down on it. And then when you're done doing that, you can unpause and then continue on with the check your understanding. All right, now the two check your understandings are very similar. So if you want to, what you can do is do the first check your understanding and unpause to check your answer, and then finish the second one, because seeing the answers in the first one will help with the second. So for this first one, we have a factory runs 24 hours a day, 3 shifts. So we have 3 8-hour shifts, day, evening, and overnight. And then the pencils are packaged in boxes of 10 pencils each. And we want 300 samples. So this is our sample population is all pencils produced. Our sample is 300 pencils. So first, describe stratified. Stratified is the one where you sort. That's what I like to think about. The word stratified is like strain or sort, like or separate, anything like that. So we're going to separate by the shift, because maybe the shifts have different, let's see, quality pencils. Maybe people are tired at night and do less quality pencils then. And so we're going to stratify by shift in case that affects it. That way we get a representative sample and we can reduce the variability in the quality. And then we'll number the pencils in each shift and use a random number generator to select 100 pencils from each of those shifts. That way we'll get a total of 300 pencils. For a cluster sample, remember the cluster sample definition was that the population was based on location. And so in this case, the boxes are the clusters. So I'm going to underline this and say kind of naturally grouped. And then when we select cluster, so we'll number the boxes, and then we'll use a random number generator to select 30 boxes of 10 pencils each. We sample all pencils in each box for a total of 300 pencils. And then the benefits are stratification reduces variability in the quality that might be due to the shifts. And I'm going to add that it's representative and guarantees all shifts represented. So that's always good, but it's mostly reduced variability is the biggest thing for stratification. And then a cluster is easier because we only have to sample entire boxes. So remember, a cluster is always entire. That's so important that you understand that part. Okay, pause again to try the last one because they're very similar, and then I'm just going to show the answers to the last one. I'm not going to talk through it. If you have any more questions, feel free to email your teacher. We'll help you out. And then do the homework, and I'll put a little visual aid in Canvas that helps with these 4 sampling methods as well that you're free to look through. So pause. And here are the answers to the last check your understanding. Pause, check, email if you have any questions.